Hi there, Joshua here. I was at school. We were learning about transformations of shapes. There was this question on the board, and my math teacher said to me, she said, can you translate this shape? I said, into English, triangle. Let's get on with the lesson. Welcome to this lesson on solving equations using recursive formulas. So last lesson I explained what recursive formulas are. They're just formulas for generating sequences of numbers. In this lesson I'm going to be solving equations with them. So to start with, I'm just going to do a quick recap of what we did last lesson, just to remind you what recursive formulas are. So as I said, they're formulas for generating sequences. Here's an example of a recursive formula. Xn plus 1 equals 2 times xn, take away 1, and I want the first term of the sequence to be 4. So x1 just means first term, so I want the first term to be 4. And xn in this formula just means the nth term, or I'm going to say the term in position n. So this just means the term in position n, where n could be any number. So what this formula is saying is you take the term in position n, where n could be any number, you double it, you take away 1, and that gives you the next term, the term in position n plus 1, if you like. So this is the term in position n plus 1. In other words, the term after the term in position n. So the formula is saying you take a term, you double it, take away 1, and that gives you the next term of the sequence. So we've been given the first term of the sequence. We need to put that in, double it, take away 1, and that will give us the second term. So 4 doubled, take away 1 is 7. And then you put the second term in to get the third term. So you do 2 times 7, take away 1, which is 13. And then you put 13 in to get the next term. So you do 2 times 13, take away 1 is 25. So with the recursive formula, to work out a term, you put the previous term into the formula. So let's just do one more. Let's put 25 in. 2 times 25, take away 1 is 49. And so on. The terms just get bigger and bigger and bigger. Now it'd be good to have a calculator with you for this lesson. So you might want to pause the video and get a calculator. It needs to have an answer button. It's usually next to the equal sign. Because last lesson I showed you a way of generating these sequences on the calculator. If you've been given the recursive formula. I'll just quickly remind you of that. First term is 4. So you type 4 equals to store that into the calculator. 4 equals. And then you press, to get that formula into the calculator, you need to press 2 times previous answer, take away 1. And you keep pressing equals to get more and more terms of the sequence. So the first time you press equals, the calculator will put 4 into the formula, because 4 is the most recently stored answer, and it will give you the answer 7. Then when you press equals again, it will put 7 into the formula, and give you the next term, 13. Then when you press equals again, it will put 13 into this formula, and give you the answer 25. And if you keep pressing equals, it will give you more and more terms of the sequence. So you could have a go at that now, see if you can generate this sequence of numbers on the calculator. Right now, before we move on to solving equations, I'm just going to do one more example of a recursive formula. So here's another recursive formula that generates a sequence, and this sequence behaves quite differently to the last one. This one equals, I want the first term to be 10 this time. So xn plus 1 equals xn plus 8 divided by 2, and I want the first term to be 10. Remember, x1 just means the first term. Let's see what happens here. So to get the second term, you put the first term into the formula. So you do 10 plus 8, 18 divided by 2 is 9. To get the next term, you put 9 into the formula. So you do 9 plus 8 divided by 2, which is 8.5. To get the next term, you put 8.5 in. 8.5 plus 8 divided by 2, I think, is 8.25. Gets a bit tricky now. 8.25 plus 8 divided by 2, I think, is 8.125. I'll stop there because it gets a bit difficult. You could try this on the calculator and see what happens. if you put, you have to press 10 equals to store 10 into the calculator. And then you have to enter this formula, so you press answer plus 8 over 2, or answer plus 8 divided by 2. Keep pressing equals and see what happens. You'll notice that the terms get closer and closer to 8. And in theory, the terms never actually get to 8, although the calculator eventually rounds the answer to 8 because it can't write all those zeros. So this is an example of a convergent sequence, a sequence that gets closer and closer to a particular number. And actually, these are the sorts of sequences we're going to be using in this lesson to solve equations. So this is a convergent sequence. Just means it gets closer, the terms get closer and closer to a particular number, and in this case, the limit of the sequence, the number that the terms get closer to, is 8. Right, so that's a bit of a recap on recursive formulas. Now I think we're ready to start solving equations. Right, so here is my first example of solving an equation using a recursive formula. So on the board I've got a typical textbook style sort of question in 2 parts. Now this method might seem a bit strange and it might be a bit unclear what's going on, but I'm just going to go through these 2 parts, and then at the end I will explain in detail why it works and what's going on. So here's the equation: x squared minus 4x plus 1 equals 0. And there are lots of ways of solving these sorts of equations, but this question is about solving it using a recursive formula. So part A says show that there is a solution to this equation between 3 and 4. So how can we show there's a solution somewhere between 3 and 4? Well, we could put 3 into this expression on the left hand side and see what happens, or we could put 4 in and see what happens. So if we put 3 in, you get 3 squared minus 4 times 3 plus 1. So what do you get? Well, it's 9 take away 12 plus 1 is minus 2. So 3 isn't a solution, we don't get 0. Let's put 4 in and see what happens. So 4 squared minus 4 times 3, sorry, 4 times 4 plus 1, we're putting 4 in. So 16 take away 16 plus 1 is 1. So when we put 3 in, we got an answer less than 0, we got minus 2. When we put 4 in, we got an answer greater than 0. So that suggests there is some number between 3 and 4, but if you were to put it in, you would get an answer exactly 0. So it does suggest there's a solution between 3 and 4. Just to make that a bit more clear, I'll explain it in another way. If you imagine drawing a graph of this expression, x squared minus 4x plus 1. So imagine you had to draw a graph of y equals x squared minus 4x plus 1. When x is 3, if you put that into this expression, you get minus 2, so the y value would be minus 2, down there. When x is 4, if you put it in, you get an answer of 1, so the y value would be 1. So, not exactly sure exactly what the graph looks like, but these points would join somehow. And you can kind of see that there must be a number between 3 and 4, right there, that if you were to put it into this expression, you'd get a y value of 0. So that does suggest there is a number between 3 and 4 that if you put it into the expression, you would get the answer 0. Right, let's look at part B. This is the strange bit. It says, here is a recursive formula. Xn plus 1 equals the square root of 4 times xn minus 1. First term 3, so next one is 3. And it says, use this recursive formula to find the solution of the original equation to 2 decimal places. Now it's not clear what this recursive formula has got to do with that equation. But the question is saying that it will give us the solution of this equation. So let's just go with it, let's just use it and generate the sequence and see what happens. And then after this bit I will explain what's going on. So the question is telling us to generate this sequence using this recursive formula, and that we'll get the solution of the original equation. So let's see what happens. So what you can do on your calculator is you press 3 equals to store 3, the first term, into the calculator. And then you have to enter this formula. Square root 4 times answer minus 1. And all that needs to be under the square root sign. So you type in square root of 4 times answer minus 1. Keep pressing equals and see what happens. I've already done this actually, and the first time you press equals, you get 3.316 dot 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 dot, and then you press equals again, and you get 3.502, and then you press equals again, and you get 3.606, and you keep pressing equals more and more times, and eventually you'll find the digits stop changing. So eventually you'll get 3.73205 dot 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 dot, and so on. And the terms seem to be getting closer and closer and closer to a particular number, and the digits will stop changing. And apparently this number that the terms get closer and closer to is the solution to the equation. It's not clear what the connection is yet, but I guess if that's true, then I guess we could say that the solution is 3.73 to 2 decimal places. 3.73 to 2 decimal places. Now how could we check that? How could we actually check that this is a solution to that equation correct to 2 decimal places? Because maybe after 1 million button presses, if you keep pressing equals, we'll start getting numbers that round to 3.74. How could we check it? Well, saying that the solution is 3.73 to 2 decimal places is the same as saying that it's between the lower bound 3.725 and the upper bound 3.735. And we could show that there is a solution between these two numbers, just like we showed there's a solution between 3 and 4. We could put these two numbers into the original equation, into this expression, and if we get one answer smaller than 0 and one answer bigger than 0, that means there's a solution in between. So let's do that. Again, you could try this on your calculator. We'll put these two numbers, 3.725 and 3.735, into the left-hand side of the original equation and see what happens. So with 3.725, you get 3.725 squared minus 4 times 3.725 plus 1. So you could try that and see what number you get. And then do the same with 3.735 minus 4 times 3.735 plus 1. So we're looking for one answer to be smaller than 0 and one answer to be bigger than 0. And actually, if you put these numbers in, when you put 3.725 in, you get minus 0.024. And when you put 3.735 in, you get 0.010. So yes, when we put 3.725 in, we get an answer smaller than 0. When we put 3.735 in, we get an answer bigger than 0. So that tells us that there must be a solution to this original equation between these two numbers. So 3.73 is correct to 2 decimal places. We've checked that. Right, so what I'm going to do now is I'm going to explain why this recursive formula gives you a sequence whose terms get closer and closer and closer to the solution of the original equation. Right, so now I'm going to try and explain why this recursive formula helped us to solve this equation. So this is the equation we had in the question, x squared minus 4x plus 1 equals 0. You can actually show the solutions to this equation graphically by drawing a graph of the left-hand side of the equation, a graph of y equals x squared minus 4x plus 1. I'll just do a sketch of that. Y equals x squared minus 4x plus 1. It looks something like this. And you can see from the sketch there are actually two solutions to this equation. Here and here. These two x values make that expression 0. They make y 0. So these are the two solutions of that equation. This one is actually between 0 and 1. This is the one we were focusing on in the question, between 3 and 4. And then the question told us to use this recursive formula to find this solution here. So how did it work? Well, this recursive formula is actually based on this equation. X equals the square root of 4x minus 1. All I've done is remove the n plus 1 and the n. So this recursive formula is based on this equation. This equation is that equation. It's just this equation rearranged. You might be able to see how to do that. Can you see how to rearrange this equation to this form? Well, you've got to basically move these terms over to the other side and then square root. Just writing it out. If you start with this equation, and you add 4x to both sides, and you subtract 1 from both sides, you're left with x squared on the left hand side, and you've got 4x minus 1 on the right hand side. And then assuming x is positive, and we were looking for a positive solution, you can just square root and you get this. X equals the square root of 4x minus 1. So this equation basically is just that equation rearranged. You can show the solutions to this equation graphically by sketching a graph of each side of the equation and seeing where they cross. The graph of y equals x just looks like this. Like that, it's a diagonal line through 0, 0, y equals x. And the graph of y equals the square root of 4x minus 1, what does that look like? Well, the square root of x graph looks sort of like that. The graph of square root of 4x minus 1 is basically, it's that graph slightly shifted and slightly squashed as well. It looks sort of like this. Something like that. So y equals the square root of 4x minus 1. X-axis, y-axis. And from the sketch you can see that this equation has two solutions because the graphs cross in two places. The solutions are this x value here and this x value here. They're the x values that make the y values the same, that make x equal the square root of 4x minus 1. And actually, because this equation is just a rearrangement of that one, these two x values are the same as those two x values there. They're the same solutions. And then we used this recursive formula. We did it on the calculator. We kept pressing equals. And the terms got closer and closer and closer to this solution here. So I'm going to try and explain with the graph what was going on. So the question told us to start by putting 3 into the recursive formula. So putting 3 into the recursive formula is basically putting 3 into that expression and finding the height of this graph, the y value of this graph. So it's like going up to the graph like that. And we got 3.316 when we pressed equals for the first time. And then we took that, taking that value and putting it back into the recursive formula is on the graph is basically like making the y value our new x value, which is like going across the line y equals x, making y the y value our new x value, and putting that value back into the expression is like finding the height of the graph for this new x value. Like that. And I think we've got 3.502. And then taking that value and putting it back into the recursive formula is like making this y value our new x value and finding the height of the graph for this new x value. And that was 3.606. And then putting that in to the recursive formula is like making that y value our new x value and finding the height of the graph again for this new x value, and so on. And you sort of get this staircase effect, and the terms will get closer and closer and closer to the solution. You can sort of see what's going on in the picture. Sometimes with these sorts of questions it's a staircase effect, sometimes it's actually a spiral effect, which is what's going to happen in the next example I'm going to do. So hopefully that explains what's going on. After a few button presses, well quite a few button presses, we saw that the digits stopped changing. And the solution was, I think, 3.73205 ... So it got close to the solution very quickly. Now, the question told us to use a starting value of 3. Could we have used a different starting value? What if we'd used a starting value of 4? Would we have got the same solution? What about a starting value of 2? If we'd started with 2, would we also get the solution? You might want to try that on the calculator, see it with different starting values and see if it still works, see if you still get that solution. Is there a starting value you can use to find this solution? Or will you always get a staircase effect going up? Because the original equation, as I said, has 2 solutions. I'll tell you this one is between, it's roughly 0.268. The one we found was, what was it, 3.732 roughly. So using this recursive formula, is there any starting value we can use to find this solution? Or will you always get this solution here? Maybe it's impossible. Maybe you'd need to rearrange the original equation in a different form to get a recursive formula to find this solution. So these are a few things to think about. But hopefully this picture shows you what's going on and why this sequence gets closer and closer and closer to this solution over here. Right, to finish off I'm going to do one more example. Right, so this is my second and last example of solving an equation using a recursive formula. So here is example number 2. So the equation this time is x cubed plus x equals 145. And this question has 3 parts. We'll go through it a bit quicker than example 1, because you've already seen it once before. So part A is show that there is a solution between 5 and 6 to this equation. Well, let's put 5 in and let's put 6 in and see what happens. So when x is 5, you get 5 cubed plus 5. That's 125 plus 5 is 130. So 5 isn't a solution, 5 is too small. When you put 6 in, you get 6 cubed plus 6. 6 cubed plus 6, 216 plus 6 is 222. So since 145 is between 130 and 222, that suggests that there's a solution to this equation somewhere between 5 and 6. And you can see that a bit more easily if I sketch a graph, x, y. Imagine a graph of x cubed plus x, y equals x cubed plus x, the left-hand side of this equation. When x is 5, y would be up here, 130. And when x is 6, y would be 222. 222. And the graph would do something like this, those points would be connected. So there must be a point in between where the height is 145. And this x value here would give you the answer 145 when you put it into this expression. So there must be a number between 5 and 6 that's a solution of this equation. Right, let's move on to part B. Part B says show that the original equation can be rearranged into the form x equals the cube root of 145 minus x. So this must be to set up the recursive formula a bit later on. So let's rearrange this equation into that form. So I'll just write it out. It's x cubed, the original equation, x cubed plus x equals 145. So how are we going to rearrange it into this form? What are the steps? Well, it looks like the x has been moved to the other side, the x term, and also the whole thing has been cube rooted. So let's do those 2 steps. Let's subtract x from both sides. That's the first step. So you're left with x cubed on the left equals 145 minus x. And if we cube root both sides, I think we'll get that. We'll get x equals the cube root of the right hand side, cube root of 145 minus x. So we've done it. We've gone from this equation to this equation, just by rearranging. Right, let's look at part C. I think they've changed this into a recursive formula. So it says using the recursive formula, xn plus 1 equals the cube root of 145 minus xn, with x1 equals 5 with starting value 5. Find the solution to the original equation to 2 decimal places. So notice all they've done is they've just replaced this x with xn plus 1 and this x with xn to come up with this recursive formula. And apparently the question is saying that this, by using this recursive formula and that starting value, we'll get a solution to the original equation. So let's try it. So the first term of the sequence is 5. And let's generate some terms of this sequence and see what happens. So you could try this on your calculator. You press 5 equals to get it stored into the calculator, and then you want to enter this expression. You want to press cube root 145 minus answer. And if you keep pressing equals, it will generate a sequence. And let's have a look at what those terms of the sequence will be. I've done this already, and I got, for the first term, for the next term, it was 5.192 dot 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 dot. And then the third term, if I pressed equals again, 5.190 dot dot dot. I pressed equals again, 5.190 dot 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 dot, and so on. So if you keep pressing equals more and more times, the terms seem to be getting closer and closer to a particular number. The first few digits stop changing after a while, and the terms seem to be getting closer and closer to a number around 5.19014, and so on. The digits stop changing after a while. So the question is claiming that the number that the terms get closer and closer to is actually the solution to this equation. So if that's true, I guess we could say the solution to this equation seems to be, to 2 decimal places, 5.19. So it seems like x equals 5.19 to 2 decimal places. But how could we check that? How could we check that this is actually the correct solution to that equation, correct to 2 decimal places? Because maybe after 1 million button presses or 1 billion button presses, the numbers will start rounding to 5.20. So how do we know that this is the correct solution to 2 decimal places? Well, just like we did in example 1, we can use bounds. Saying that the solution is 5.19 to 2 decimal places is basically the same as saying that the solution is between 5.185 and 5.195. So what we can do is we can put these two values into the original equation, just like we did with 5 and 6 to check there was a solution between 5 and 6. We can put these two numbers in. If one of them gives us an answer less than 145 and the other one gives us an answer more than 145, then we'll know that for some value in between, the answer should be exactly 145. In other words, there's a solution in between these two numbers. So let's do that. Let's put 5.185 into the original equation. So if you do 5.185 cubed plus 5.185, you can see what you get. And then do the same with 5.195. 5.195 cubed plus 5.195 and see what you get. I've done this already. You get, for the lower one, you get 144.57, and so on. Just under 145, and for the bigger one, you get 145.39, 45.39. So one of the answers was lower than 145, one of the answers was bigger than 145. So that means that the solution to the equation must be in between these two x values. So it is 5.19 to 2 decimal places. That is correct. We've checked it. Right, what I'm going to do now is I'm going to wipe the board, and with a couple of pictures, I'm going to explain what's going on in this question. Right, so to finish the lesson off, let me explain that last example with pictures. So this was the original equation, x cubed plus x equals 145. And you can show the solution to this equation in a picture if you just do a graph of the left-hand side of the equation, a graph of y equals x cubed plus x. A sketch of it would be something like this. Y equals x cubed plus x. X-axis, y-axis. And it's going to reach a height of 145 at some point. So there's going to be some x value where the graph has a height of 145. And this is a solution. This is the solution of the equation. This is the x value where that equals 145, and that's what we were trying to find. And we learned it was somewhere between 5 and 6. And then the question told us to rearrange the original equation into a different form, into this form, x equals the cube root of 145 minus x. And actually, if you're trying to make up a recursive formula, you need to get x on its own on one side of the equation. So that's what the question was doing. It was just setting up a recursive formula. So we rearranged it into that form. You can actually show the solutions to this equation graphically by drawing the left-hand side as a graph and by drawing the right-hand side as a graph. Right, so the left-hand side is y equals x. So we had that earlier, it just looks like this. Y equals x. The right-hand side, y equals the cube root of 145 minus x, looks something like this. This is y equals the cube root of 145 minus x. And the graphs cross in one place, and that tells you that this equation has one solution. So this particular x value. This is the x value where the y values are the same. In other words, where x equals the cube root of 145 minus x. So it's the solution of this equation. And it's the same number as that number there, because these equations are the same. They're just rearrangements of each other. And then the question we just did, it sort of changed this into a recursive formula. It replaced this x with xn plus 1, and it replaced the x on this side with xn. And then it told us to use a starting value of 5 to get closer and closer to the solution of this equation, this equation, same thing. So we put 5 in, and then I think we got an answer of 5.192 something, and then we got an answer of 5.190 something, and so on. And we seem to get closer and closer to a number. So let me use this picture to show what was going on. So it told us to start with the number 5. So putting 5 into this recursive formula is basically, it's like finding the y value of this graph. It's just like going up to the graph and finding the y value. And that's about 5.192. And then taking that answer and putting that answer back into the recursive formula is basically making that y value our new x value. And then putting it into the formula is again like finding the y value of this graph for this new x value. So it's like going to the graph again. And I think we got 5.190 this time. And then putting this value into the recursive formula is basically, it's like taking this y value, making it our new x value, and putting this new x value into here and finding the height of the graph for that new x value. So it's like doing that. And then we made that our new x value, and we put that into the recursive formula, and we made that our new x value, and then put that in, and so on. And you get this sort of spiral effect, getting closer and closer to the solution, which I think, if I remember, was something like 5.19014, and so on. So that's what was going on. Hopefully this picture explains it a bit more clearly, and hopefully you've got a better understanding now of how you can use recursive formulas to solve equations. So that's it.